When people talk about the future of artificial intelligence, the conversation almost always starts with faster chips. Every new generation of AI hardware promises more computing power, higher memory capacity, and record-breaking performance. The assumption seems obvious. Whoever builds the fastest processor will dominate the AI industry. But what if that assumption is becoming outdated? Today's most advanced AI systems aren't powered by a single chip. They're powered by thousands of processors working together at the same time. And as those computing clusters continue to grow, a different challenge is beginning to emerge, one that has nothing to do with adding more transistors or increasing clock speeds. The real question is no longer how quickly one processor can perform calculations. It's how efficiently thousands of processors can exchange information without slowing each other down. Even the world's most powerful AI chip becomes far less valuable if it spends a significant portion of its time waiting for data to arrive. That hidden delay is quietly becoming one of the biggest obstacles in modern AI infrastructure. In fact, many engineers now argue that communication between processors is evolving into the next defining factor of AI performance. Faster chips alone are no longer enough. The entire system has to move information at extraordinary speed if organizations want to fully utilize the computing power they've invested billions of dollars to build. This is exactly where a new technological race is beginning to take shape. Recent reports suggest that China has been investing heavily in next-generation AI networking technologies designed to move data across massive computing clusters with far greater efficiency. Rather than focusing only on building more powerful processors, the strategy appears to target the invisible infrastructure that keeps those processors working together as one unified system. If that approach proves successful, the implications could extend far beyond benchmark scores. It could reshape how future AI data centers are designed, influence where technology companies invest billions in infrastructure, and redefine what it actually means to lead the global AI race. Today on Future Structures, we're exploring why communication between chips may become just as important as the chips themselves, how NVIDIA has spent years building an advantage in this area, and why China's latest networking developments are drawing attention across the semiconductor industry. For years, the AI industry measured progress by one simple metric: build a faster processor. Every product launch focused on more computing cores, greater memory bandwidth, and higher performance numbers. That strategy worked when AI models were relatively small and could be trained on a limited number of machines. But today's frontier models operate on an entirely different scale, and that has changed the rules of the game. Modern AI training no longer happens inside a single server. It takes place across enormous clusters containing thousands, and sometimes tens of thousands, of accelerators working simultaneously. Each processor is responsible for only a fraction of the overall workload, constantly performing calculations while coordinating with every other processor in the system. That coordination is where things become complicated. Every training cycle requires an enormous exchange of information. As one processor completes its calculations, it immediately shares updated data with the rest of the cluster before the next round of computation begins. This process repeats continuously throughout training, often millions of times before a model is complete. The challenge is that these processors can only move as fast as the communication network connecting them. Imagine an orchestra with thousands of musicians. Every performer may be exceptionally talented, but if the conductor's instructions arrive late or sections fall out of sync, the entire performance suffers. Individual skill becomes less important than coordination across the entire group. Large AI systems operate in much the same way. A delay affecting only a small percentage of the network can slow down thousands of processors simultaneously. Instead of performing useful work, expensive hardware remains idle while waiting for the next batch of information. Those lost moments may seem insignificant, but when multiplied across massive AI clusters running around the clock, they translate into enormous financial costs. This is one reason today's AI infrastructure has become so expensive to operate. Building a cutting-edge data center requires billions of dollars in processors, memory, storage, cooling systems, and power infrastructure. Organizations expect those resources to remain busy as much as possible. Every second a processor sits idle represents wasted capital, unnecessary energy consumption, and lower overall productivity. As AI models continue to expand, this problem becomes even more pronounced. Adding more processors does not automatically deliver proportional performance gains. Beyond a certain point, communication overhead begins to grow faster than computational capacity. Without an efficient network, simply increasing the number of chips can create diminishing returns, where additional hardware contributes less performance than expected. This shift has fundamentally changed how engineers think about AI infrastructure. Instead of asking, how can we make one processor faster? The more important question has become, how can we make thousands of processors behave like one highly coordinated machine? That subtle change in perspective is influencing nearly every major technology company investing in artificial intelligence. It is also helping explain why networking technologies, once considered supporting hardware, are now moving to the center of the AI conversation. And no company has recognized that transformation earlier than NVIDIA. For many people, NVIDIA's success seems straightforward. The company builds some of the world's fastest AI processors, and demand for those chips has exploded. But looking only at the GPU tells only part of the story. Over the past decade, NVIDIA has gradually transformed itself from a graphics chip manufacturer into a provider of complete AI infrastructure. That evolution has become one of the company's biggest competitive advantages. Training modern AI models requires far more than raw computing power. Organizations need processors that communicate efficiently, software that distributes workloads intelligently, networking hardware capable of moving enormous amounts of data, and development tools that allow researchers to scale projects without rebuilding their entire computing environment. NVIDIA recognized this shift early. Instead of selling hardware as individual products, the company began assembling an integrated platform where every component was designed to work together. GPUs became only one piece of a much larger ecosystem. Its high-speed networking technologies help connect thousands of processors with extremely low latency. Communication libraries optimize how data moves between computing nodes. System software manages workloads across massive AI clusters, while complete server designs simplify deployment for cloud providers and enterprise customers. This level of integration creates a powerful advantage. Now, when companies invest billions of dollars building AI infrastructure, they don't simply want fast processors. They want reliable systems that maximize performance from every piece of hardware. An integrated platform reduces compatibility issues, simplifies maintenance, improves efficiency, and shortens deployment time. Those operational benefits often matter just as much as benchmark performance. That's why NVIDIA's business has expanded well beyond semiconductor manufacturing. Today, customers increasingly purchase an entire computing environment rather than assembling separate components themselves. The GPU may receive most of the public attention, but networking, software, storage architecture, and system optimization all contribute to the final performance delivered inside an AI data center. This broader strategy has helped NVIDIA establish a leadership position that extends beyond chip design. But success on this scale also changes the nature of competition. Any country or company hoping to challenge NVIDIA cannot simply introduce a faster processor. It must develop an ecosystem capable of supporting advanced AI workloads from beginning to end. That realization appears to be shaping China's long-term strategy.